Now we are seeing a case from the topic impact of jets and vanes. And the topic here is the force exerted by jet on a curved vane. And here the case is jet impinges on a fixed curved plate at the center. So here jet is striking a fixed curved plate at the center. And if you see here the jet leaves and before that if you see just the initial conditions, jet is coming out of nozzle or pipe, and it is impinging or it is hitting the fixed curved plate at the center, and after striking it is leaving tangentially to the plate or blade plate. So when it is leaving, it is making an angle of theta with x direction, and in the initial case the velocity will be v. Velocity of the jet is v, and a is the cross sectional area of the jet. Theta is the outlet jet angle or outlet angle of jet. Here theta is outlet angle of the jet, and m dot is mass flow rate, that we can write as w by g into a into v. And if you see here initial velocity of jet in the x direction, you see that is we are taking it as v1x, and that will be v only. And final velocity of the jet in the x direction, v2x. Here if you see after striking, the jet is moving like this. And if you just resolve that into two components, one is along the x and one is along the y. And I told this jet is making, while it is leaving, it is making angle of theta, means we are taking that as theta, the x direction. So it will be moving like this, means the x component will be moving like this. So that is a final final velocity in the x direction, that is we are taking it as v2x, and that will be v cos theta, because this component will be cos component. So that will be v cos theta we're taking, and here the negative sign indicates that this v cos theta is in the negative x direction. If you see, this is the negative x direction. And if you see force exerted by the jet in the x direction, so in any case if you see force exerted by the jet, you will write just simply m dot into v1 minus v2, and here we are taking in the x direction, means we are taking v1x and v2x. M dot will be w by g a v, and v1x is v we have seen, and minus v2x we have seen it is minus of v cos theta. So just when you simplify here, w by g into a into v, minus of minus plus, and v plus v cos theta. So you can take v common here, so it is 1 plus cos theta. And when you simplify this, this will be w by g into a into v square, and 1 plus cos theta. This is the force in the x direction, that is Fx. Similarly, if you see, initial velocity of the jet in the y direction will be 0. So why? Because the jet is just going, it is straight. So in the exact horizontal direction, so in the y direction its velocity will be 0 in the initial stage. So you can say initial velocity of the jet in the y direction v1y is 0, and final velocity of the jet in y direction v2y is v sin theta. After or when it is striking and when it is leaving, so it is the main component is going like this, and when you resolve that, so this is the y component. So final velocity of the jet in the y direction will be in this way. So it is v2y we are taking, and this will be v sin theta. We have seen this is cos theta, so this is sin theta. So it is v sin theta. And here if you see force exerted by the jet in the y direction, so you can write once again m dot into v1y minus v2y, because in the y direction. So m dot is nothing but w by g into a into v, and v1y we have seen it is 0, and minus v2y v sin theta, and this first term will be 0, and it is when you multiply here, it is minus of w by g into a into v square sin theta. So here the negative sign indicates that force is acting downward direction, means downward in the y direction, downward direction the force is acting. So for more videos, please subscribe and activate bell symbol, and also please share my videos with your friends. Thanks for watching.